All right, everyone, we are on our last problem. We're going to do our ANOVA. So there's a couple typos here that we're going to be working with the warp beaks data sets. We're going to be seeing if wool and tension impact breaks at a 1% significance. What variables significantly impact breaks? Quantify the size of the effect of each variable. Determine what set of variables which under conditions would produce the highest number of breaks. So let's go ahead. We're going to go in and we're going to actually, let me move this a little bit. I want to look at my data set, warp beaks. I just want to take a peek at it. So I've got breaks, and then I've got wool and tension. So I'm going to say as factor, I'm going to say warp breaks. I'm going to set wool as a factor, and wool is going to be R2. I'm going to set tension as a factor, warp peaks, and that's going to be our third. And then finally, I'm going to set my breaks as a numeric, and I'm going to say that warp breaks. Excellent. So I'm going to set that. I'm going to look at my data set. Great. So I should expect 1 degree of freedom for wool, 2 degrees of freedom for tension. Everything else treated as numeric. Fantastic. So I'm going to see how breaks is affected by wool, and then tension, and tension. Excellent. Go through here. We see, wool is just, we're at 1%, so it's not even close, because we need to be less than 0.1. So wool is not statistically significant. Tension is. Wool and tension is not either, although it's very, very close. But at 1% significance, it's not. Let's see. Tension is a large effect. Wool, I would say, is a small effect. And wool tension is kind of like a medium effect. So again, it's close. Something we may want to consider, definitely depending on what we have. Let's go ahead and we're going to do our games how test. And we're going to look at how breaks is affected by, for example, let's look at breaks versus wool. So if we look at, and then I'm going to also look at this. I want to look at my data here. I'm going to plot. So I want to plot, and I want to look at X is going to be equal to wool. This is going to be equal to breaks. And then, so, so close. So our p-value has to be less than 0.01. Actually, not even close, in order of magnitude. So they're statistically the same, so A or B would produce the same number of breaks. If we look at tension and breaks, and I'm going to look at this here, breaks and tension. Now let's look at this guy. Okay, so 0.01. So only L and H are statistically significant. So L and M are not statistically significant. L and H are, and M and H are also not statistically significant. So this is a hard one to kind of, specify. So, based on the mean, this is one, L and H are statistically different, but these overlap. So I would say L or M. Now you could say, well, L and M, but L is statistically distinct from H. So I would say L or M. But you definitely couldn't just say L, because L and M are statistically the same. So I think that would be kind of the key idea here. This is different from this, so you wouldn't want to say all three for sure. So L or M. And that's it. So see you on the next problem. Thanks. Bye.